I'm going to do some examples here from 5.2, doing hypothesis test for a population mean. And here's our scenario. We always need to start in a hypothesis test with identifying the null hypothesis and the alternative hypothesis. The null hypothesis is what we believe or assume the population mean to be. And in this case, we're talking about class GPAs, and the preferred or assumed mean for the population is 2.75 for the GPA. That's our null hypothesis, that the population mean is 2.75. Now, someone is running a hypothesis test because they think there's evidence that the GPAs are actually higher than 2.75. So our alternative is going to be the GPAs are actually higher than 2.75. And so we have our null and our alternative hypothesis about the value of the population mean. And the significance level was stated in the problem to be 0.05. And our conclusion about the hypothesis test is always based upon the stated significance level. If the p-value comes back to be less than the significance level, we will reject the null hypothesis in favor of the alternative. If the p-value is larger than the significance level, then we fail to reject the null hypothesis. We don't prove it to be true. There's just not enough evidence based off of our sample to reject the null. So let me show you first. I'm going to do this two ways, this hypothesis test. First, I'm going to use the data analysis method. I don't really like this method because it has a few weird steps in it, but I'm going to show it first because it is kind of quick once you get the hang of it. Make sure you're on the correct sheet. Depending on the version of the problem, it'll tell you what sheet to use. I'm using sheet 2 here. Now, data analysis doesn't have a one sample hypothesis test, so you have to make up a second sample that's completely bogus, and you just want to put zeros in there, a couple zeros. This is your second sample. So we have to do that because in data analysis, we need to use the t-test. We always use the t-test as opposed to the z-test when we do not know the population standard deviation, and that's almost always the case. If you knew the population standard deviation, you would have a lot of information about the population. You would probably know the population mean as well, and you wouldn't need to hypothesize about what it is. So we're almost always going to be using the t-test when we do a hypothesis test because we don't know the population standard deviation. And so there is no one sample option, so we're going to use two samples and we're going to assume unequal variance. Hit OK, and now let's select our two samples. So your first sample, click here. I'll just show you how you need to do it in case you don't have the right values there. Delete everything and then come and select your sample of data or type in those cells. And then for your second sample, I'm going to do that again, delete it, and then select where you put the zeros at. The next thing to enter here is the hypothesized mean difference. What are we hypothesizing the difference is between the means of our two populations? Well, our first population, the null hypothesis for our population mean is 2.75. Now this is our actual data, our actual sample was gathered from this population, and we're hypothesizing this is the mean. Now our second sample, it's just made up zeros. It has a mean of 0, a standard deviation of 0. It's just all zeros. And so the hypothesized mean of this sample is 0. So the difference between 2.75 and 0 is 2.75. So whatever your null hypothesis is, that's what you enter right here. Enter in what your value is for your significance level right there. And then where do you want your output? So again, you can just delete that, click wherever you want it to show up, and hit OK. And then you get your results pretty quick here. So it shows you, scroll over here, the mean of your sample pops up, and you're going to need to enter that. X with a bar over it, X bar is the sample mean, so I'm going to type that in here. Now we also need the t-test statistic and then the p-value for that test statistic. And that's listed right here. We have our t-test statistic right here. And then we are doing a one-tailed test. Two-tailed is when your alternative is not equal to, but if you have just greater than or you have just less than. Here we have just the greater than sign. That's one-tailed hypothesis test. And so you have your p-value then based off your test statistic. And so we type those values in, and since the p-value, you just compare it to your significance level here. This is less than that, and that determines the conclusion of your hypothesis test. Since it's less than the significance level, the null hypothesis is rejected. If it was greater than, that's when we fail to reject. And in this context, if we're rejecting the null hypothesis, we're assuming the alternative is true, and that is this is the alternative right here, that the GPA is actually greater than 2.75. So we're assuming that's true. Sufficient evidence exists that the population mean is actually greater than 2.75. Now I want to come back here and do this a different way without using data analysis. We're going to get the same results. We're just going to come up here in 5.2 and see the procedure for a t-test, and we're going to work out this calculation here by hand. We're going to take the sample mean, subtract our null hypothesis on top, divide by the sample standard deviation, divided by the square root of the sample size. That gives us our t-test statistic, and then there's a formula in Excel that gives us the p-value for that. So I'm going to show all of that. So back here in Excel again, I've copied that formula over for the t-test statistic, so we have it here on the screen. Getting that mean of the sample, you can just do equals average, grab all the data here. When I close the parentheses, I'm going to get that mean. Let me add a few more decimal spots here. You see it's the same exact mean we got with the other method. Now to get the t-test statistic here, I need to do this calculation. So on top, I'm taking the sample mean minus my null hypothesis for the population mean. So first, let me just do the top calculation. It's going to be that result I got here. Let me just click it here. Our sample mean minus 2.75, because that is my value for my null hypothesis for my population mean. That's what's going to go on top of this fraction. Now on bottom, I need to first figure out what is my sample standard deviation. So stdev.s, because we have a sample. Again, I'm going to select my data. There's my sample standard deviation. I need to divide that value by the square root of the sample size here. So let me write out here that I'm doing the bottom calculation here. This is the value I got on top, x bar minus my population mean. And on bottom, I have the sample standard deviation divided by the square root of the sample size. So let me take square root of 50. I have 50 pieces of data here in my sample. I need to take that sample standard deviation and divide by the square root of the sample size. So let me do that. Let me take my sample standard deviation and divide by, and you can just click in Excel where your numbers are so you don't have to retype them. Taking that blue value divided by the red value, sample standard deviation divided by square root of sample size. So this is what I get on the bottom. And so to get the final result for the t-test statistic, just reduce that down, take the top divided by the bottom. And so my t-stat is going to be that top number and divide it by what you got on the bottom. And so you get that same result, and you don't have to make up a second sample with all zeros in it. I just think it's a little cleaner this way, a little more intuitive. And also, I don't like how this has a less than one-tailed, when really we're doing a right-hand tail test here. Our alternative hypothesis is that the population mean is greater than 2.75. And so if you look at the formula we need now to get the p-value, you do t.dist. This is a left-tailed student's t-distribution. We want to do the right-tailed one. All right, so make sure you do t.dist.rt and type in, I can just click here again, what is your t-stat? And then what's your degrees of freedom? Degrees of freedom is always one less than your sample size. In this case, 50 minus 1 is going to be 49. Let's put a 49 there, close my parentheses, and you're going to get that same value for the one-tailed test. It's just a little more clear this way that it's a right-tailed test. The way that's written there, I think that's a little more confusing that we're doing a right-tailed test. But we're getting the same results, and that's the other way you can go about getting them. We reach the same conclusion. This is less than our significance level, so if the p-value is less than your significance level, that means you reject the null hypothesis. There's sufficient evidence to support the alternative hypothesis. So let me do one more here. I'll go through it a little bit quicker. In this scenario, our null hypothesis, we're kind of doing a quality control check here, which is a very common way hypothesis tests are used in the business world. So our null hypothesis is that a light bulb will last this given number of hours. The population mean is 11,000. And we want to actually see, we'd be concerned if we're telling customers that their light bulb is going to last this long, but it's actually less than that. So we're going to check with our alternative to see if there's actually evidence that the population mean is actually less than 11,000. So we have a one-tailed test again. We're concerned about the population mean being less than our assumed null hypothesis, which is that the population mean is equal to 11,000 hours. So we have a stated significance level. If we want to use the data analysis, we have to just make up a second sample with zeros in it. And then we go data analysis. We do not know the population standard deviation, so we use the t-test, and our only option here is with two samples. Make sure you have the correct range here. Our sample size is only 45 in this example, and make sure you're on the right sheet as well. Your second sample is the zeros you made up. The hypothesized difference between your means is going to be whatever your null hypothesis is, because our second sample has a mean of 0. And then type in your significance level. Wherever you want the output, type that in here. I'll put it right there. And you get your sample mean, your t-test statistic, and you get the p-value for that test statistic. And notice it looks the same as my previous example with that less than or equal to. But this time it's doing a left-tailed test because we have a less than for our alternative hypothesis. So this does give you the right or the correct tail of the test, even though this still says less than. It'll do a right-tailed or left-tailed correctly for your one-tailed test. But that will always look the same right there, so don't be confused by that. Doing it the other method, you can quickly get the population mean equals average A1 through A45. That's where my data was. Let me go over there, make sure that's what's selected. All right, A1 through A45. You get your population mean. I'm going to need to find the top part of this, which is the population mean. Or sorry, I said population mean. This is the sample mean. You get the sample mean, and you subtract your null hypothesis for what you're assuming the population mean is, and that is what goes on top of this calculation. To get the bottom, you get your sample standard deviation. Standard deviation dot S for sample, A1 through A45. And then you need to divide that by the square root of the sample size, which in this case is 45. So I need to divide those two numbers. So I'm going to take sample standard deviation, divide by square root of the sample size. That is my bottom value. Now to finally calculate the t-test statistic, you take the top number and divide by the bottom number. And so you're going to get that same result we're doing a left-tailed test. We have a less than for our alternative hypothesis. So the p-value associated with this test statistic is going to be t-dot distribution. You see right here it says we're doing a left-tailed test, so that's the one I want. That's my test statistic. Degrees of freedom is 1 less than your sample size. So 45 minus 1 is 44. And you always want to type in true for cumulative. And there is your p-value. And from there, you're ready to reach your conclusions about the test. If the p-value is less than the significance level, reject the null hypothesis. There is sufficient evidence to support the alternative. If it's greater than this value, then there's insufficient evidence to reject the null. I'm not going to go all the way through this one at all. I just want to talk a little bit about setting up the null and the alternative hypothesis. In this scenario, we're looking at utility poles, and we're assuming that the population mean is exactly 40 feet. That's how tall they need to be. They can't be taller than that, and they can't be shorter than that. We need our poles to all be the same height. So our alternative is a not equals to. A not equals to 40 is the alternative hypothesis, and that gives you a two-tailed hypothesis test. So this is the same data from the previous problem I worked out. I'm not going through the third problem here, but when you do the data analysis method, make sure you're looking, like you see the mean in the same spot, you see the t statistic in the same spot, but make sure your p-value, you're looking at the two-tailed version, because if you have a not equals alternative hypothesis, it's a two-tailed test. And if you're doing this method, and you're going to go through the same approach to get your t-test statistic, but to get your p-value, t.dist, notice there's one with a dot 2t, which means two tails. So when you do that, it says here it's a two-tailed test. You're going to go through the same motions here where you click on your test statistic and then enter your degrees of freedom, which is 1 less than the sample size. But you'll need to use that different formula for a two-tailed test.